Now, one of the reasons that the different recipes have such different textures, even though the glutenins, the glutenin molecules are about the same distance apart, is that one can actually modulate the interactions between glutenin molecules. So you'll remember our formula for the elastic modulus, E is equal to U over L cubed. So what we've just talked about is L, that is the distance, right, that is the cross-link distance. I mean, the distance between the glutenin molecules isn't the same as the cross-link distance, but it's got to be somewhere in that range. But the other way, of course, to change the elastic modulus is to change U. And when you're baking, there are several ways of doing that, which I now want to just go through and remind you of. So one is that if you coat the glutenin molecules with fat, with something that's actually hydrophobic, you can weaken the interactions between the glutenin molecules. And that's because the fat will coat the hydrophobic residues in the stretched out glutenin molecule and cause the interactions between two glutenin molecules to be weaker than they otherwise would be. So oftentimes when a recipe has butter or shortening or some other type of fat, that fat is going to end up, depending exactly on the preparation of the recipe, coating the glutenin molecules, and that actually has the feature that it will weaken the elastic network of the glutenin. And that's certainly true in cakes, right? I mean, the reason that cakes are so much more tender in part than breads is because of the fat content that's in the cake. So another way actually that you can modulate the strength of interactions between glutenin molecules is to change the pH. This shouldn't be a surprise to you. We've talked about the role of pH in modulating protein interactions before. So it turns out that if you lower the pH, you actually make the glutenin molecule more charged, which means the glutenin molecules repel each other more, which actually lowers the strength of their interaction, which will tend to make the glutenin network more tender. Now, you might say that I don't dump acid. I'm not putting vinegar in my cake. There's no acid in baking, but actually that's not true. Acid is a very, very important part of baking. And to illustrate this, I just want to show you this table, which has in it the typical pHs that there are in ingredients that you might use while baking. Okay, so in our table of common baking ingredients, let's start with vinegar. Of course, you don't tend to use vinegar when you bake, but it's a good acidic ingredient to use as a sort of null. So vinegar has a pH which is somewhere between 2 and 3, depending on the type of vinegar. So one common baking ingredient which is quite acidic is buttermilk, which has a pH of 4.5. So another thing that you might add when you're baking often are fruit ingredients. So for example, you might be making an apple pie. And apples, it turns out, have a pH around 3 or 3.1 or so. So depending on when you put your apples in the recipe, if you were to try to actually mix the apples directly with the gluten when it was developing, you would actually weaken the bonds between the gluten. And so on and so forth. This is something else that you have to keep in mind and is a difference between the different recipes.